Welcome to Lesson 7, Modeling Equations of Lines. So today's goal is to be able to create an equation that models a real-world situation. Before we get to that, though, I want to kind of touch one more skill that I want us to make sure that we have, and that would be dealing with parallel and perpendicular slopes. So parallel slopes, lines are parallel if they have equal slopes, if their slopes are the same. So for this one right here, if I were to graph that blue equation, y equals 2x plus 4, and graph the red equation, notice the two lines don't get any closer or farther apart. That is because they are parallel. And then perpendicular. So perpendicular lines have slopes that we say are opposite reciprocals. So when we say opposite reciprocals, so the word opposite means they have opposite signs. So this one's positive, this one's negative, right? That's what the opposite means. Reciprocal means the number is flipped. So you can think of 2, if it's a whole number, you can think of it as 2 over 1. And then if you flip that, it becomes 1 over 2. So that's the reciprocal part. So if you were to graph these, so if I graph the blue one, and if I graph the red one, notice they hit at 90 degrees. That's what it means to be perpendicular. They hit at 90 degrees. And again, that's what the slopes look like of perpendicular lines. So let's use that, do a few examples where we actually use that. So passing through the point 3, -1, and parallel to the line with equation y equals y minus 2x equals 5. So the directions say write the equation of a line with the given conditions. All right, so I want it to be parallel to this line. So I got to figure out what's the slope here, okay? And for me to do that, I'm going to put it in slope-intercept form. I'm going to get the y by itself. So I'm going to start with that. So y minus 2x equals 5. I'm going to add 2x to both sides. Y equals, and here we have 2x plus 5. So now I can figure out what the slope is. The slope here is 2, which means now I'm going to create my line. And I want it to be parallel, so I want it to have the same slope, right? So I know my m is going to equal 2. And it's got to go through this point. So I have a point, 3, -1. And what I'm going to do is I'm going to use the point slope form that we talked about last lesson. So that's y minus y1 equals m times x minus x1. So here's my x. I can put that into there. My y, put that into there. And my m, my slope, I put that into there. So we have y minus -1 equals 2 times x minus 3. So technically there's my equation. It's in point slope form. But for us to kind of use them as functions later on, we're going to want to put it in slope-intercept form. And all that means is we've got to get the y by itself. I'm going to do that in a couple steps here. So the minus and negative, I'm going to make that a plus right now. So y plus 1 equals, I'm going to distribute the 2. So 2x minus 6. And now I'm going to get rid of that plus 1. I minus 1, minus 1. I end up with y equals 2x minus 7. So that is the equation of the line that is parallel to this line and goes through that point. All right, let's take a look at the next one. Passes through -6, 4, that's my point, and it perpendicular to the line with the equation. So I want to be perpendicular to this line. So I got to figure out what's the slope of this line, and I can do that by putting it in slope-intercept form. So we have 3x plus 2y equals 8. All right, so I'm going to get y by itself. So minus 3x minus 3x. So we have 2y equals negative 3x plus 8, right? I can't put these together. They're not like terms. They have to stay as two separate terms. And then divide by 2, divide by 2, divide by 2. Y equals negative 3 over 2, because that doesn't divide, so I'm going to leave it as a fraction, x plus 4. All right, so now I see what my slope is, right? Here's my slope. Now I want to be perpendicular to that slope, right? So for my line that I'm going to create, my slope has to be the opposite reciprocal. So it's going to be positive 2/3. All right. So, and my point that I'm going to use is negative 6, 4. So again, I'm going to start with my point slope form. So y minus y1 equals m times x minus x1. So I'll plug my x in, plug my 4 in, and plug my slope in. So we have y minus 4 equals 2/3 times x minus x1, which is negative 6. All right, so I'm going to start to simplify this. Y minus 4 equals 2/3 x. This is minus a negative, so it's going to be plus. Times it by 2. When you're timesing a fraction to a whole number, you times it to the top, right? So 6 times 2 is 12. 12 divided by 3 is 4. Lastly, get rid of this minus 4. We plus 4. We plus 4. And I get y equals 2/3 x plus 8. All right, hit pause, see if you can create the equation that passes through 9, 3 and parallel to the line with the equation, so parallel to that equation. All right, so parallel to this equation. So the first thing I need to do is figure out my slope. So we have x minus 3y equals 10. Get y by itself, so I'm going to minus x minus x. Now here the minus stays with this y, so it's minus 3y equals negative x plus 10. Then I'm going to divide everything by this negative 3. Oh, sorry, divide by negative 3. Divide by negative 3. Y equals. So here, this doesn't divide evenly, but they're both negative, so that cancels. So I'm going to call this 1/3 x minus 10/3. So it looks like we might have to deal with a fraction at some point. Oh no, this is not for that. But I did figure out my slope is 1/3, right? That's my slope. And I want to be parallel, so I need the same slope, right? Now, it looks like I'm running out of room here, so I'm going to see if I can. No, let me shrink everything up. All right. So my m equals 1/3 because I want it to be parallel, so it has to be the same. And my point is 9, 3. So my y minus y1 equals m times x minus x1. So y minus 3 equals 1/3 x minus 9. So here we have y minus 3 equals 1/3 x minus 9. So 9 times 1 is 9, divided by 3 is 3. And here we'd add 3 and add 3. So the 3's cancel off both. So your final equation, you can write it as y equals 1/3 x, or you can write it as y equals 1/3 x plus 0. Either one of those is good. All right, so that's the last skill I kind of wanted us to have. But let's start thinking about modeling now. So here we have a some data that's been graphed, and the bottom is the diameter of like a tree trunk. Okay, so like if this is the trunk, the distance across, right? That's your diameter. That's what this is. So they measured a bunch of diameters of trees, the stumps, or the trunk, I should say. Maybe they didn't cut it actually down. And then here they recorded how tall the tree is. So we have a tree, right? They recorded how tall it is, its height. And if you notice, they're not on a perfect straight line, right? That doesn't happen in nature, right? If you're trying to model a real world behavior. But what you should notice is these points seem to be pretty close to a line. They kind of form a line. And so what we can do is we can make a line that closely resembles our data, and then we can start making predictions, right? Because let's say I measure a diameter of a tree and I get that it's 8 centimeters, right? So then I can use my model and I can figure out how tall it is, what its height is, right? So I can then use my line here to make predictions. So that's kind of what we're going to be looking at today. We're going to have a real world data, which isn't perfectly on a line, but we're going to model it with an equation. And so we can make predictions. All right, inmate population. The number of people in millions in U.S. prisons or jails grew at a constant rate from 2001 to 2009, with 1.345 million people incarcerated in 2001 and 1.617 million incarcerated in 2009. What is the rate of growth of people incarcerated from 2001 to 2009? All right, so first of all, right, this is using that phrase that we're going to have to get used to, rate of growth or rate of change, right? What does that mean? That means slope, right? So normally in algebra class, we refer to it as slope. But now we're going to start talking about real world situations. You're going to start seeing the phrase rate of growth or rate of change or rate of decrease, right? This rate, that's our slope. So what this is saying find the slope. Okay. So then I have to recognize I actually have 2 points here, right? In 2001, there's 1.345 million people. So that's a point. In 2001, there's 1.345 million people. Now, which one goes where? Normally, most often I would say if there's a time or a year, that's almost always your x value. We almost always put the time in the x position. And if you look down here in Reddit, it tells you year they want years to be x, right? So that's another way I can figure it out. And then they give me another point, right? They say in 2009, there's 1.617 million people. That's another point. So in 2009, there's 1.617. And I got to figure out my slope between these 2 points, right? Or my rate of growth. And for that, I can just use my slope formula because I have 2 points. So y2 minus y1 over x2 minus x1. So for me, that's going to be 1.617 minus 1.345 minus the y's on top. And then on the bottom, we have 2009 minus 2001. So then I simplify that. I subtract the tops, and I get 0.272 over 8. And then I divide that, and I get 0.034 for my slope, or my rate of change. So let's think about that for a second. Remember in one of our first lessons, we said, what does that mean in context? So we should always kind of think about that. When we get our answer, what does that actually mean in context? So what does this mean? This is the population of the prison or jail's increase by this much every year. It's the rate of change, right? The population of jails and prisons is increasing by this much, this many million every year. It's the rate of change of the prison population. It's positive, right? So the inmate population is going up. It's increasing every year. All right. And here, B says, write a linear equation that models the number n of prisoners as a function of the year x. So instead of using y, they want me to use n, and I'll plug that in at the end for it. I'm going to start with just my normal function, because what do I have here? I have my m, 0.034, and I have a point. In fact, I have 2 points, and it doesn't matter which point you pick, you'll get the same answer. So I'll just pick that first point, 2001, and 1.345. All right, and so now, just like our last examples, I'm going to start with my point slope form, which is y minus y1 equals m times x minus x1. And I'm going to plug my information in. So we have y minus y1, which is 1.345, equals m, which is 0.034, times x minus x1. Oops, sorry, not x1. Plug in the value, which is 2001. All right, now I'm going to simplify this. I'm going to put it in slope-intercept form. So I'm going to distribute that into here, and so I'm going to get y minus 1.345 equals 0.034 minus 68.034. Add 1.345, add 1.345. We get y equals 0.034 minus 66.689. And with that, what I'm going to do, x minus, is I'm actually going to type that there so I can copy it to the next page, because now we're going to use this formula that we just created. And I'm going to use the n. They wanted me to use n. The prison population equals 0.034. Oops. 0.034 x minus 66.689. All right. I'm going to copy this. There's our equation, because our next thing is going to ask me, so here's the thing we just created. Okay. Now it says the number of people incarcerated in 2011 was 1.7 million people. Does our, that's the wrong R, right? Does our model agree with that number? All right, so let's talk about that for a second. First of all, let's talk about this equation. What exactly is this equation doing? What's its purpose? So you plug in the year into this thing, and then it will produce a predicted prison, jail population. That's what this does. So here in 2011, let's plug that in and let's see what our prediction is and see if it's close to what it actually was. All right, so n equals 0.034 times x, which is going to be 2011, minus 66.689. And we multiply that together and we get 68.374 minus 66.689, and that gets me 1.655. So if you look at that, they're close, right? They're not exact. This doesn't give us exact answers. We've modeled real world, so it's giving us a prediction about what it should be. But it seems like our model worked pretty well. Let's try another example. Modeling, so high school enrollment. So the table below shows the enrollment in thousands in grades 9 through 12 at U.S. public and private schools for the even years between 1990 and 2008. So on top, they tell us there, that's going to be our X's, right? So there's our points, our dates, our even dates, right? Every other year. And then here's the enrollment of students in thousands. And when it says in thousands, that means to get the actual number, you would multiply this by 1,000 to get the actual number. Here it says create a scatter plot of data. Does it appear that it can be modeled with a linear function, right? Because if you make these points and it's like a curve, you wouldn't want to use a linear model. We'd want to use something else. So let's see if we can use a linear model to do it. So here I went to Desmos, and over on that left side I clicked the plus, and you can click table. And so then I started putting in the dates, 1990, 1992, and Desmos is pretty smart, so it kind of figures out what I'm doing here. So now I just hit enter and it automatically fills in the dates all the way down to 2008. And then I actually obviously have to type in all the Y values, and I didn't want to bore you with that, so I sped up the tape here a little bit so I can get those in there real quick. And notice once I'm done, I don't see any points, because look where I am. I'm right at the origin. So if you go over there to the left and click Zoom Fit, it zooms to where your data is. And look at that. That's pretty nice. It's not a perfect straight line, but it's pretty close to a line, which means, we can predict using a linear model. So let's do that. So we'll do something similar to what we did on the last one. So first thing I'm going to do is find the average rate of change of the high school enrollment between 1990 and 2008. All right. So again, average rate of change. What does that mean? It means slope, right? That's the slope. From 1990, so I'm going to use this point to 2008 and this point, right? I'm going to figure out what is the rate of change between those 2 points. So again, my 2 points are 1990, 12,488,000, right? That's times by thousands to get the actual number. We get 2008, 16,715. All right, so my slope formula so we have 16,715 minus 12,488. We have 2008 minus 1990. And if I do that calculation, I get 4,227 over 18. And if I divide that, I'll get 234.83 repeating. I'm just going to round that, though, to 234.8. That's my slope. And again, what does this mean in context, right? What does this mean in context? First of all, it's positive, so we're increasing by this many students, this many thousand students every year, right? That's its rate of change. The student population or the student enrollment is increasing by this much per year, okay? All right, now it says write the equation of the line determined by the rate of change from B, right, what we just did, that's this guy, this will be my rate of change, and one of the 2 points. And again, it doesn't matter which one you pick, you're going to get the same answer. So I'll just pick this top one here. So my point is going to be 1990 12,488. And my slope is going to be 234.8, my rate of change. And again, I'm going to use my point slope form, which is y minus y1 equals m times x minus x1. All right, so I plug in my values. So I have y minus 12,488 equals 234.8 times x minus 1990. All right, distribute. I'm going to distribute the slope inside. So we have y minus 12,488 equals 234.8x minus, and that becomes 467,252. Add 12,488. Add 12,488. Y equals 234.8x minus 454,764. Now again, I'm going to use this now. This is my prediction equation. I'm going to use this on the next slide to make a prediction. So again, I'm going to type it so I can copy it over easily to the next screen. Okay, let's get this. So y equals 234.8 x minus 454,767. All right. Copy. And let's go to the next screen. So now it says use that function, right? Use our function right here and figure out what the enrollment is in 1995. So here I know what it is in 1994 and I know what it is in 1996. I want to figure out what would it be between those two. And let's see if this thing gives us, a number that would make sense. So again, let's talk about what does this equation actually do, right? So the idea is you plug the year into this thing, and it produces the school enrollment. It predicts what the school enrollment will be. So let's try 1995. So y equals 234.8 times 1995 minus 454,767. And then if I simplify all this, I get y equals 13,662. And if I look at that number, it looks like that would fit nicely between those two numbers. So again, is it giving us exactly what it was in 1995? Probably not, because again, remember these points weren't on a perfect straight line, but it was very close. So I'm guessing this number is going to be very close to what it actually was in 1995. So again, we're using a linear model to make predictions of the real world. This is going to be the last example here. Magazine advertising. The amount spent on magazine advertising was $15.5 billion in 2009, and it is expected to decrease at a rate of $0.65 billion per year over the next 5 years. Write an equation for the amount of magazine advertising spending as a function of the number of years after 2009. All right. So here it says expected to decrease at a rate of, right? So they're actually giving me my slope. But since it's decreasing, right, it's getting smaller, should my slope be positive or negative? It should be a negative. So my m is negative 0.65, right? It's decreasing by 0.65 every year. That's my slope. Remember, slope is the same thing as the change, the rate of change. All right. And actually, they want it to be from number of years after 2009, right? So they don't want you to put the year into this equation. What they want you to do is how many years after 2009. That's the number you're supposed to put in there. So if I want to find 2010, I don't put 2010 into the equation. I put 1 because 2010 is 1 year after 2009. So basically 2009 is our starting point. Well, that's what this is, right? Now, in normal algebra, we'd call this the y-intercept. And it is the y-intercept. But we kind of want to more think of it as it's the initial value, right? It's the starting value, right? And what is that? It's the amount spent in 2009. That's our starting value. And so that's going to be our b. So here, instead of using point slope, I can use the slope-intercept form, y equals mx plus b, because I have my slope, I have my y-intercept. So y equals negative 0.65x plus 15.5. There's our equation. Now it says use that to figure out what the estimated amount spent for magazine advertising in 2019. All right, so we're going to use that y equals negative 0.65x plus 15.5. And again, here, what do you plug in here? You don't plug in the year, you plug in the years after 2009. And then it's going to tell you the amount spent on advertising ads. Spent on ads, okay? All right, so they are saying, okay, how much is spent in 2019? So first I have to figure out, well, how many years after 2009 is 2019, right? And I can just do that by going 2019, take away the 2009, and I get 10, right? So this is 10 years after. So that's why I plug into my x. So I have y equals negative 0.65 times 10 plus 15.5, which equals negative 6.5 plus 15.5, which equals 9. 9 billion was spent on advertising in magazines in 2019. So kind of it's decreasing because companies aren't advertising as much in magazines. People don't buy as many magazines anymore, right? It's all online nowadays. So that's why it's decreasing. All right, looking at my clock here, this was kind of a longer video, so we're not going to do an epilogue today. So after this video, you can just get started with the problem set. Again, contact me if you get stuck on any of them or need some extra help.